Have a nice day, my dear students. Today we will discuss about the most important topic of electrical engineering is electrical braking of DC motor. Okay, so myself, Mr. Santanu Noskar, Assistant Professor of Electrical Department GKCM JIS Group, and my mail ID is santanu.uit@gmail.com and santanu.noskar_gkcm@jisgroup.org, and this is my Facebook page, Being Electrify with Santanu. So let's start. So here is the course of your electrical engineering machine 1. So general introduction of rotating machine, which I have covered in my previous lecture. Then DC generator, working principle, construction, types of DC generator, function of interpole, compensating winding, armature winding, lap and wave, EMF equation, method of voltage build-up, which is called OCC, critical resistance, critical speed, concept of flux distribution in DC machine, armature reaction in DC machine, commutation method, concept of reactance voltage, application of different types of DC generator. This all I have covered in my previous lecture about DC generator. Now please come to DC motor. Working principle, back EMF, speed and torque equation, characteristics of series shunt compound, method of speed control, starting method, 3-point and 4-point starter, losses, efficiency, and the last which I will discuss about is the braking method of DC motor, regenerative braking, counter current braking, and dynamic braking. Okay, and about the application of different types of DC motor I have discussed in every slide of mine. Okay, so today we will discuss about the braking method of DC motor. After that, after this video I will discuss about the single phase transformer. So let's start. So what is an electrical braking of DC motor? Electrical braking is usually employed in application to stop a unit driven by motors in an exact position, or to have the speed of the driven unit suitably controlled during its declaration. Electrical braking is used in application where frequent, quick, accurate or emergency stop are required. Electrical braking allow smooth stops without any inconvenience to passenger. When a loaded host is lowered, electrical braking keeps the speed within safe limits. Otherwise, the machine or drive speed will reach the dangerous value. When a train goes down a steep gradient, electrical braking is employed to hold the train speed within the prescribed safe limit. Electrical braking is more commonly used where active loads are applicable. In spite of electric braking, the braking force can also be obtained by using mechanical brakes. Now comes to the disadvantage of mechanical braking and why electrical braking is needed. So the main disadvantages of mechanical braking are as follows. It requires frequent maintenance and replacement of brake shoes. Okay, and then braking power is wasted in the form of heat. Now, in spite of having some disadvantages of mechanical braking, It is also used along with the electric braking to ensure reliable operation of the drive. It is also used to hold the drive at the standstill because many braking methods do not produce torque at standstill condition. Now comes to the advantages of electrical braking over mechanical braking. So point wise I have mentioned in this PPT. So number one, electrical braking is fast and effective than mechanical braking. Okay. Number two, electrical braking doesn't involve high maintenance cost unlike mechanical braking. In mechanical braking, we need to replace brake shoes periodically, which involves high maintenance cost. Number three, amount of heat generated in electrical braking is very much less than that of heat produced due to mechanical braking. This heat produced in mechanical braking at brake shoes leads to failure of brakes. In electrical braking, a part of electrical energy is returned to supply, which helps in reducing the running cost. Now, then using electric braking, the capacity of the system like higher speed, heavy loads can be increased, which cannot be obtained through mechanical braking. And the last, because of the above advantages, we use electrical braking to stop DC motor instead of using mechanical braking. So now you have understand that why we use electrical braking over mechanical braking. So this question may arise in our exam, that why we needs electrical braking over mechanical braking. Okay, now go through the types of braking. Okay, so there are three types of electric braking in DC motor. They are regenerative braking, dynamic or rheostatic braking, and flogging or reverse current braking. So at first go through the regenerative braking. So go through this slide. This is the application. This is regenerative braking in DC shunt motor and regenerative braking in DC series motor. One by one I will describe all those things. So first, what is regenerative braking? In regenerative braking, the power or energy of the driven machinery, which is in kinetic form, is returned back to the power supply mains. These types of braking is possible when the driven load or machinery forces the motor to run at a speed higher than no load speed with a constant excitation. Now, under this condition, the back EMF EB of the motor is greater than the supply voltage V, which reverses the direction of the motor armature current. The machine now begins to operate as a generator. So regenerative means it regenerate the machine. Okay, so the machine now begins to operate as a generator, and the energy generated is supplied to the source. Regenerative braking can also be performed at a very low speed if the motor is connected as a separately excited generator. The excitation of the motor is increased as the speed is reduced, so that the two equations shown below are satisfied. The two equations are Eb equals to Np phi Z by A, where Eb is back EMF, N is the speed, P is the number of pole, phi is the flux per pole, Z is the number of armature conductor, A is the path through armature, and V equals to Eb minus Ia Ra. The motor does not enter into saturation on increasing excitation. Regenerative braking is possible with shunt and separately excited motors. In compound motors, braking is possible only with weak series compounding. So look here, the current is negative sign, armature current is negative sign. So in name, what is the name? Regenerate. So it regenerate the machine and it's operate like a generator, and the energy generated is supplied to the source. Now the application of regenerative braking. Regenerative braking is used especially where frequent braking and slowing of drives is required. It is most helpful and useful in holding a descending load of high potential energy at a constant speed. Regenerative braking is used to control the speed of motor driving loads such as in electric locomotives, elevators, cranes, and host. And last of all, regenerative braking cannot be used for stopping the motor. It used for controlling the speed above the no load speed of the motor driving. The necessary condition for regeneration is that the back EMF EB should be greater than the supply voltage so that the armature current is reversed. Look here, armature current is reversed and the mode of operation change from motoring to generating. Okay. Now regenerative braking in DC shunt motors. Under normal condition, the armature current is given by the equation shown below. Here, when the load is lowered by a crane, hoist or lift causes the motor speed to be greater than the no load speed, the back EMF becomes greater than the supply voltage. Consequently, armature current IA becomes negative. The machine now begins to operate as a generator. So this is for DC shunt motor. Now regenerative braking in DC series motor. In case of DC series motor, an increase in speed is followed by a decrease in the armature current and field flux. The back EMF EB cannot be greater than the supply voltage. Regeneration is possible in DC series motor since the field current cannot be made greater than the armature current. Regeneration is required where DC series motor is used extensively, such as in traction, elevator, hoist, etc. For example, in an electro locomotive moving down the gradient, a constant speed may be necessary. In hoist drive, the speed is to be limited whenever it becomes dangerously high. One commonly used method of regenerative braking of DC series motor is to connect it as a shunt motor. Since the resistance of the field winding is low, a series resistance is connected in the field circuit to limit the current within the safe value. Now go through flogging or reverse current braking. Okay. In plugging or reverse current braking, the armature terminal or the supply polarity of a separately excited or shunt motor when running are reversed. Please listen one more time. In plugging or reverse current braking, the armature terminal or the supply polarity of a separately excited or shunt motor when running are reversed. Okay. Therefore, in plugging, the supply voltage V and the induced voltage EB, which is also called back EMF, will act in the same direction. Thus, during plugging, the effective voltage across the armature will be V plus EB, which is almost twice the supply. The armature current is reversed and a high braking torque is produced. An external current limiting resistor is connected in series with the armature to limit the armature current to a safe value. The connection diagram of DC separately excited motor and its characteristics is shown here. Okay, where V is the supply voltage, RB is the external resistance, IA is the armature current, IF is the field current. Similarly, the connection diagram and the characteristics of series motor in plugging mode is shown here. Okay, for braking a series motor, either the armature terminal or field terminals are reversed, but both armature and field terminal are not reversed together. Reversing of both the terminal will give only normal working operation. At the zero speed, the braking torque is not zero. The motor must be disconnected from the supply at or near zero speed when the motor is used for stopping a load. If the motor is not disconnected from the supply means the motor will speed up the reverse direction. For disconnecting the supply, centrifugal switch are used. Okay, the method of braking known as plugging or reverse current braking is a highly insufficient method because in addition to the power supplied by the load, power supplied by the source is also wasted in resistance. Now the application of plugging. The plugging is most commonly used for following purpose: in controlling elevator, rolling mills, printing press, machine tools, etc. Now go through the dynamic braking or rheostatic braking. In dynamic braking, please go through this method and then I will describe the application. So in dynamic braking, a braking resistor RB is connected across the armature as soon as the DC motor is disconnected from the supply mains. The motor now works as a generator, producing the braking torque. For the braking operation in dynamic braking, the motor is connected in two ways. Firstly, the separately excited or shunt motor can be connected either as separately excited generator where the flux is kept constant. The second way is that it can be connected to a self-excited shunt generator. Okay, with the field winding in parallel with the armature, the connection diagram of dynamic braking of separately excited DC motor is shown here when the machine work in the motoring mode. Okay, the connection diagram is shown here when braking with the separate excitation is done. Okay, the RB is inserted, so braking has done. Now the connection diagram is shown here when braking with self excitation is performed. Okay, this method is also known as rheostatic braking because of an external braking resistance is connected across the terminal for electric braking. During an electric braking, the kinetic energy stored in the rotating parts of the machine and the connected load is converted into electric energy. When the motor is working as a generator, the energy is dissipated as heat in the braking resistance RB and armature circuit resistance is RA. The connection diagram of dynamic braking of DC shunt motor is shown here. Okay, when the machine is working in the motoring mode, then the connection diagram of shunt motor braking with self and separate excitation is shown here. Okay, now for dynamic braking, the series motor is disconnected from the supply. A variable resistance RB, this is the series motor, a variable resistance RB shown in the figure is connected in series and the connection of the field winding are reversed. Look here, an RB is inserted here. So the field connection are reversed so that the current through the field winding flows in the same direction as before from S1 to S2, so that the back EMF reduce the residual flux. The machine now start working as a self-excited DC series generator. In self-excitation, the braking operation is slow. Hence, when a quick braking is required, the machine is connected with the self-excitation mode. A suitable resistance is connected in series with the field to limit the current to a safe value. The dynamic or rheostatic braking is an insufficient method of braking because all the energy which is generated is dissipated as form of heat in the resistance. Now, the dynamic braking application. The dynamic braking technique is used to stop a DC motor and widely used in industrial application. These systems are utilized in the application of fans, centrifugals, pumps, rapid or continuous braking, and certain conveyor belts. These are used where rapid slowdown and reversing are required. These are used on rail cars through several units, trolley buses, electric trams, light rail vehicles, hybrid electric and electric automobiles. Now these are the reference of my lecture, Electrical Machine by Asfaq Hussain Harun Asfaq. This book is very good book for diploma and BTech electrical engineer. Now Principle of Electrical Machine by VK Mehta, Rohit Mehta, which is also a good book for BTech and diploma engineers. Now the best book according to my choice, which is Electrical Machinery by Dr. P.S. Bhimra. This book is little bit tough for diploma engineer but okay for BTech engineer. If you understand the book, then all thing will be clear to you. So some reference site, NPTEL videos lecture, electrical is easy and circuit globe. Now this is my Facebook page, Being Electrify with Santanu, and this is my YouTube channel, Being Electrify. Please like, share, subscribe and comment to my channel. Thank you. Hope you all are enjoying my lecture.